Solving Riemann sums with a table can seem complicated, but it's actually pretty easy. So for a left Riemann sum, what you would want to do is first look at the table and you would see that there's 4 subintervals here. So you could draw a number line with 4 subintervals in it. 1, 2, 3, 4. And then put each point, put each x onto the bottom of the subinterval. So 0, 3, 6, 9, 12. Each of these is conveniently 3 units long, so you would put a 3 here to remind yourself that's what you multiply by. Then you take, because it's a left Riemann sum, you would take the left value of each subinterval and put it above that interval. So for example, you would put 2 here, 3 here, 4 here, and 2 here. You then multiply each of these together and add them up. So you can do 3, because they're all 3's, times 2 plus 3 plus 4 plus 2. And you end up getting 33. For a right subinterval, for a right Riemann sum, you do something very similar. It starts out the same, so you have the number line with the 4 subintervals. And then, instead of taking the left value of the subinterval, you take the right value. So it would be 3, 4, and then so on, 2 and -1. So each of these is also 3 units, so 3, 3, 3, and 3. So then you would do the same thing you did here, 3 times 3 plus 4 plus 2 minus 1. And this will end up being 24. Now, midpoint Riemann sum can be a little more complicated, but it's still pretty easy. So in this case, I would want 2 subintervals so that we have the midpoints. So 2 subintervals on a number line. So 0, 6, 12 would give me 2 even subintervals of 6. Now we want to take the midpoint of each interval and put it on top of that interval. So the midpoint of 0 to 6 is 3, or the value of the midpoint, x equals 3 is also f of x. And then 6 and 12, that's 2. So you end up doing 6 times 3 plus 2, which will end up being, sorry, 30. I can do math. Okay, and so yeah, that's how you do them, and they look complicated, but they're actually very easy.
Yay!